So in this video, what we're going to check out is how to go about classifying a first order differential equation as separable or non-separable. So first order would just mean your differential equation depends only on first derivatives, and then ordinary means it does not depend on partial derivatives, which is something you learn about in Calculus 3. So a differential equation that just depends on first derivatives is considered to be separable if each x and then the differential dx can be separated or placed on the opposite side of the equation from each y in the differential dy. So here I've got a few questions from a problem set from a textbook that ask us to determine whether the differential equation is separable. So we've got two differential equations here. I like to go with Leibniz notation whenever I'm using separation of variables, just because then the rules of algebra kind of dictate what you're going to be doing to go about doing the separation. So I'm just going to re-express both of these differential equations in Leibniz notation. One of these two differential equations is separable. The other one is not separable. So if you're trying to classify as separable or non-separable, it's just going to come down to algebra. You have to try to get the dx on the right side of the equation in the numerator with all of the x's, and you're going to have to try to get this y over on the other side of the equation with the dy. Now, one thing that you could do right away is you could multiply both sides by dx with this one. So if we multiply both sides by dx, what we end up with is we end up with the dy over here. We have the dx with all of the x's here, but then there's this y sitting right smack dab in the middle of the right side of this equation, and that's an issue. We're going to have to try to get that y over here. Well, what you could do is you could divide both sides by y minus x, but when you divide both sides by y minus x, you're taking the y off of the right, but you're also taking an x with it over to the left side of the equation with the differential dy. Now we have a mixture of x's and y's over here, which is definitely an issue. So it doesn't really seem like that's going to work. So let's just kind of backtrack here. Let's get back to square one and think about another option. So I think the other most obvious option would be to distribute here right away. So if you distributed, you're going to get 2xy and then minus 2x squared. Still going to have dy dx over here. Now if you wanted to divide both sides by y, I see this mistake made from time to time. If we divide both sides by y, key word there is sides. I have to divide this by y too. So although that would get the y off of this term and produce a y on the side of the equation that's eventually going to contain the dy, we end up with a y in the denominator of this term. So that doesn't really work. And truthfully, when you're trying to separate your variables, you're going to like whenever your equation is in a factored form, as this already is. It's already written as multiplication. And we've considered doing some algebra here, and it doesn't really seem like there's any way for us to get the dx and all of the x's over here and the dy with all the y's on the left. So this is going to be a differential equation that is not separable. So this one would be classified as not separable. Now over here, if we check out this second equation, which looks more complex just by first glance, this one is actually going to be separable. Now, I just got finished saying we're going to like when our equation is in a factored form. I'm going to take a minute to factor the right-hand side of this equation. So we have a common factor of x on both of these terms. If I take that common factor out of this first term, I'm left with 2 cosine of y. If I take that out of this second term, I'm left with minus y cubed. Now what I can do is I can multiply by my dx. So I'm going to multiply both sides by dx to get the dx, the differential dx, over on the right side of the equation. So all I'm going to be left with here is a dy. And then if I wanted to get the y's to the other side, I can divide by this great big quantity here on both sides. These are going to cancel, and what we're left with is we're left with x dx on the right, so the only variable x and the differential dx, and then on the left we're left with dy over 2 cosine of y minus y cubed. So this differential equation is separable. We'll talk about how to solve separable differential equations in a separate video. So this one, not separable. We couldn't get the dx and the x's on one side, the dy and all the y's on the other. This one, after factoring, we were able to accomplish that goal. So this is a separable differential equation.